So images and image formats are where we're going to start today. And if we take a look at images as they're represented on the screen, I'm sure you've heard the term pixels, right? I'm not talking about little fairies. I'm talking about the little dots, and they're actually square dots that make up every single image that we see. Now, when you have a memory of when you were a kid sitting super close to the TV, what that would look like, and you could see the individual little dots in the screen. Um, my parents used to tell me that that would make me go blind. Thank God it didn't, because I probably sat way too close to the television a lot. But if you look closely enough at an image, or if you enlarge it enough, you will see something that looks just like this. And in fact, this section of this strawberry is what you have enlarged here. Every dot in this image has 3 or 4 numbers that define the color. The 3 numbers would define the color, and a 4th number sometimes exists to define the transparency of that pixel, depending on which type of image it is. And I'll get into that a little bit more later, but let's focus on the 3 colors right now. And the 3 colors that make up every pixel of every image on your screen are red, green, and blue. And those values can range from 0 to 255 on each one. And if I have 0, 0, 0, that's black. If I have 255, 255, 255, that's white. And that's how images are represented. So as we are doing things to an image, we're actually just changing the values for red, green, and blue. So red, green, and blue are what make up every color of every image that we see online or anywhere. So an image format, we really talk about 3 major image formats, and there's a bit of a historical development here, because when we started representing images on screens in color, we were limited as to the number of colors, first of all, so the images didn't look very realistic. But as the number of colors that were possible in an image grew to this now modern idea of 256, 256, 256, which, if you think about it, gives us 256 times 256 times 256 possible colors. I think it's 14 million something possible colors. So our image file size grew as we started adding all of these colors. But then something else happened simultaneously in the world that made us sort of rethink how we do images, because these big file sizes were no longer practical. And that thing that happened at that time was the growth of the internet and the World Wide Web. Because you see, what we couldn't do over a really, really slow internet connection, probably nobody in this room can relate to a slow internet connection, but it used to be that we actually cared about that, right? We would dial up through our phone, our landlines, and hear this god-awful screeching noise, and then it would connect after like 5 minutes. And downloading a picture of somebody's cat used to take another 5 minutes. It wasn't instant like it is now. That's my I walked uphill both ways in the snow to school story for you. But what we realize is, like, oh crap, we've got these really big images, and now people want to send them or put them on their web pages or send them on emails. So what we figured out is, how can we create a new image format that compresses the size of the image as much as possible while still keeping the quality of the image as good as we can? And so we came up with a few options. One of the first options, graphics interchange format, lovingly both known as GIF or GIF, depending on where you fall, and you think the Trump-Harris divide is bad, you should get into an argument online over whether it's pronounced GIF or GIF. For the record, I sort of flip back and forth between the two because I still haven't settled it in my mind. But the creator of the format says that it should be pronounced GIF. And most people say, that's stupid. I don't give you a gift for Christmas, right? Um, it's a gift. So anyway, GIF or GIF, either way, it works by doing a few things. Okay, the GIF format reduces the number of colors in an image to only 256 possibilities. Now that's fine for a lot of things. If you're doing a cartoon character or a logo or a comic book or any kind of drawing, you're not really concerned about millions of colors because 256 is mostly fine. Like if you think about the Pepsi logo, right? Even at a high resolution, the Pepsi logo has 3 or 4 colors in it. So 256 is kind of a luxury. But if we reduce the number of colors in an image, the size goes way down. The other thing that GIF does is it actually can do horizontal row compiling. And all that means is that it it takes the rows, and if you have 5 pixels of the same color, instead of saying blue, 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 it says 5 times blue. It's like when we use that print shorthand to print a row of asterisks on Python. It's a much shorter way of representing horizontal rows of data. So if you take, it's interesting, if you take an image that's black and white stripes that are horizontal and you save it as a GIF, and then you take that same image and you turn it 90 degrees so that the stripes are vertical and you save it as a GIF, there'll be a huge difference in file size because GIF is really good at horizontal striping. It doesn't do vertical striping. So it's interesting that that's the thing that it does. Also, famously, right, does animation, which is what we know GIF for. We don't really care about the compression ability anymore. What we care about is being able to send funny animated memes to our friends. And so animation is something that does. It was also the first format to be able to produce transparent images. Prior to GIF, every image was rectangular in shape. You couldn't change that. But with GIF, what you can do is you can pick one of those 256 colors that's in that image, and you can say every pixel that is this color, one only, every pixel that's this color is now transparent. And so that produces a form of transparency that, while it was advanced for the time, now it looks a little crappy, to be honest with you, because we have a better mode of transparency that we've employed in some of the more modern formats. So GIF was an early entrant into the image format for compressed images that we use online. We still use it all the time. I don't see it going anywhere because it's fun, it's simple, and it has kind of a nostalgic vibe to it when you make something that's an animated GIF. The next format I want to talk about is called JPEG, Joint Photographic Experts Group. The reason for the existence of JPEG is right in the name. This is a format that was designed to be good at reducing the size of photographs, because what people realized is that GIF wasn't going to do that, because a photograph, you take a photograph of literally anything. You could take a photograph of this carpet, which looks like it has like 3 colors in it maybe, and the photograph of the carpet would actually have still hundreds of thousands, if not millions, of colors in it, because photographs have very subtle variations in color that make them look real. That's because that's what our eyes can see. Our eyes can actually see many, many more than 14 million colors. And so a photograph feels more real than a drawing because of that depth of color. And so the Joint Photographic Experts Group said, we need to come up with a format that's not going to reduce the color. So we got to figure out a different way. And so what they used is called interpolation. And interpolation says, what we're going to do is we're going to apply a level of compression. You can compress it from 1 to 10. And 10 is high quality and 1 is lowest quality. But the more you compress that photo, the smaller the file size, but also the quality of that photo goes down. And in a JPEG, the way you see that is artifacts or little blocky things appearing in the photo. Because what's happening is it's taking if we have that picture of the strawberry, let's say, right? We've got all of these pixels that are different colors. Well, it might take 1 pixel and then it might go over 5 pixels. And it's going to actually eliminate the pixels in between them. And it's going to use a mathematical formula to just, when it shows the picture, it's just going to guess at what those middle pixels are. And if you think about that in 2 dimensions, so it'll take this pixel, this pixel, this pixel, this pixel, and everything in between them is gone, then we're just mathematically trying to guess at what's in there. That's what interpolation means. It's basically a mathematical guess. So what happens to the quality of the picture is as the compression gets more, we have a bigger space in between the pixels that are actually there. And there's more guessing going on. And the more we guess, the worse it looks, because it's just a guess. It's not real. Right? By the way, that's why, you can't take a picture that's tiny and enlarge it without it looking kind of crappy, because when you're enlarging, you're still just guessing at what's there. The whole idea where they have those crime shows, right, where they have a blurry security camera footage of somebody doing a crime like half a block away and their face is blurry and they're like, let's enhance that right there. And then all of a sudden their face is crystal clear and you can see the stubble on their face and like every facial feature is perfectly clear. That's not real, not to that extent. We're doing better interpolation using AI now, but it's still guessing. Like it doesn't have that data. If the resolution is bad, if the pixels aren't there, they're not there. So you can't create them except by guessing. So JPEG is good at photos, high color, that kind of thing. So GIF is good for things with a few colors. Logos are good. Line drawings, comic books, cartoons. JPEG does much better at photos, period. Anything with lots of color or subtle, like if you want to take a picture of the sunset and you do it as a GIF, what you're going to see is bands of color as the gradient goes from like blue to red. It'll be bands of color because that's what a GIF does. A JPEG is going to be better at that subtle change in the color. Now, as the internet became more like what you have today, and it became faster and our machines became more powerful, we stopped worrying so much about the file size because we didn't have to. What we started worrying about was how can we make really good looking pictures? We still care a little bit about file size, but we care more about quality. So we created portable network graphics, also known as a PNG file. So the nice thing about PNG is that it still uses a mathematical formula to compress the size of the file, but it's what's called a lossless format, which means you are not going to lose quality in the image when you compress it. So the formula for PNG actually can accomplish the file size reduction without messing up the quality of the picture. It's much more advanced than either of these two older mathematical formulas. PNG also does something called alpha transparency. And what that does is it adds a fourth number. We have the red, green, and blue for each pixel, but now we also have the alpha layer or the alpha transparency number that represents or controls how transparent each individual pixel is. So now we could have a pixel that's 50% transparent so you can see what's behind it, or have those colors interact if you have multiple images on top of each other. So it gives us a lot more control, and we can have an image that fades from not transparent to completely transparent. So we have a much higher quality in terms of the image itself, but then we can throw in that ability to make it alpha transparent. It's even better.